Thank you. Hello and welcome back after lunch. I'm very pleased to introduce Eamonn Boyle. He has over 20 years experience as developer, architect and team lead, and is currently the VP of Gearset's Belfast office, working on their core Salesforce DevOps solution. Last year at NIDC, Eamonn discussed how typecast was introduced at Gearset in 2022. This year, he'll give us an update on how that is going and look at some of the language features he's enjoying in TypeScript and some of the other main language in Gearset stack, C#. Over to you, Eamonn. But I want to say that we hope to have some time for questions at the end, so consider what questions you may have for Eamonn. Thank you.
I don't know if anybody went to Paddy's talk just before lunch about imposter syndrome. Paddy's one of my colleagues at Gearset, and his talk was so good that I've now got massive imposter syndrome over this talk. So thanks for that, Paddy. So my talk is a bit of it's a bit of a mix. It's a little bit of an update on last year's talk. It's a little bit about why we want to stay up to date, and then if we can get time at the end, talk about some language stuff, which is the stuff that I find more fun. So a little bit on me. Yeah, so my name is Eamonn Boyle. I'm the VP of Engineering at Gearset, and Gearset is one of the Diamond sponsors this year. We opened up our Belfast office last April to try and have another pool to grow our engineering team, just because we're have so much ambition. And last year we were the Diamond sponsors as well, which was just absolutely fantastic, which is why we're back this year. We had a stand last year, we have a stand this year, come and see us. I did a talk last year, I'm doing a talk this year, come and see it. Oh, you're here, good, it worked. So yeah, what I'm going to do is I'm going to talk a little bit about what I began talking about last year. We started our migration to TypeScript. We were about 4.5 months into that migration. I'm a big fan of TypeScript from before, and I basically told everybody, go off and do this. If you're using JavaScript, go off and do TypeScript instead. So there's a little bit of an update on that. See, was I giving you a bum steer? Have we changed our minds? Then a little bit talking just about sort of, should you do migrations in general? Should you keep things up to date? And some of the stuff around that. And then, as I say, talk about the code. So a reminder of our stack. We were historically using Knockout on the front end with JavaScript. And then we had started a migration of React whenever I joined the company. And then we did a migration to TypeScript. And that's sort of the bulk of what I'm going to talk about. We're also using sort of C#. These are sort of fairly stable, sort of practical choices across the board. We're running in AWS, but using Kubernetes in an EKS cluster, and we're using Postgres for our persistence. And as I say, we're generally a pretty pragmatic company. We're not using like too shiny. They're all sort of pretty safe choices. We've got some data around that, so if you look at Stack Overflow and look at the numbers, JavaScript and TypeScript are up there in terms of the most popular languages. I think JavaScript's the most popular in the world, and TypeScript being a superset of JavaScript is sort of a pretty safe choice. And C# there again in the top 10, really safe language. And the thing I like about TypeScript and C# is they're both really pragmatic languages. In terms of the frameworks we're using, React is #1 there in terms of the web frameworks, and again ASP.NET Core, which we're running with, is again in the top 10. Really safe choices. Postgres as persistence layer, most popular. Okay. Now, I'm not saying that being popular is everything. Not exactly a great fan of these folks. Being popular is not everything, but in our line of work, there are some real advantages to going with the popular choice, of going with the thing that there's numbers behind, okay? If you're following the well-trodden path, or if you're using something that's tried and tested, if you're using something that there's lots of community, you get some of these big wins. There's generally going to be more bugs ironed out, right? More people using it, more people stressing it. The bugs are going to be ironed out, okay? You're going to have better documentation. So as you're learning it and the complexity of the systems that we're using these days and the change that's there, you need really good documentation. It's heavily used. It's probably going to be there, either community or active contributors on that. You're going to have more contributor activity. So actually, one thing is identifying the bugs, another thing is fixing the bugs. And all the stuff around that with the community, with a large user base, things like posts on Stack Overflow, people setting up forums, blog posts on Medium and the like, videos, online training, all the tools, libraries that you sort of come with that. So you don't have to roll your own. If you're an early adopter, you're choosing a language that you're like, oh, I really love this language, but I haven't got like a good, I haven't got enough users behind it. Like you're going to be rolling your own and spending your time doing that instead of building out, the thing that's actually going to deliver value for your customers. And just basically, it's going to be easier to like get people into the company to actually support you build the features. Because again, if you've like got a passion for Haskell and that's your foundation for your system, you're probably going to have difficulty getting other people to help you build out that system. And then there will be a time where like everything is going to come out of support. If there's a large enough community behind it, you're gonna that's gonna have like longer longevity, and even after the fact, it could be like community supported, like long after the fact. So we've a pretty sort of we're pretty comfortable sort of making some of these choices. But as I say, we're using TypeScript now, but we weren't before. We're using React now, but we weren't before. So should we just always go for like the new shiny thing? Should we always jump to the most popular thing? I would say no. I would say in general, be very aware of migrations, be very aware of rewrites. They're generally a bad idea. Okay, I know like last year I said, hey, everybody make the jump to TypeScript. More on that later, but they're generally a bad idea. They're generally going to be quite costly to do. It's going to be harder than you think. There's always going to be more issues than you expect. While you're doing this, there's an opportunity cost because you're not delivering value. You're basically doing this work to arrive at the exact same place, and you're going to introduce like loads of issues along the way. There are exceptions to this, okay? So like we obviously made our migration. There are exceptions. So lack of support is like one of the reasons why you might want to migrate. You may be sort of forced into it because of that. It could be that there's some performance issues as well, and it could be that your existing code base is just in a state where it's untenable to support, it's untenable to maintain. It's holding you back. So there are sort of exceptions to this. For our TypeScript migration, again, there's good technical reasons why we could do this. We're getting, in theory, all of these benefits, and we can sort of talk about that. But before we even get to there, TypeScript is this superset of JavaScript. So it's just adding the static typing, which gives us all of these benefits. But you can basically expand on your legacy code. You can interop with your legacy code. Your legacy code is going to benefit from it. So you can do it in a very gradual way. You don't have that upfront cost. You don't have that opportunity cost. You can start with just your new stuff being built in this new system that's going to give you all of these benefits. So TypeScript as a migration is sort of an easy technical choice, and there's other ones that are there as well. So yeah, I talked like last year about all the benefits of TypeScript. You come and grab me, and I can definitely spout on more about that. But in terms of the migration choice, it's an easy win. Little update on where we got to. This was the graph I showed last year. We were 4.5 months in. So our JavaScript files, which is the yellow line, was going down, and we were migrating our existing JavaScript to TypeScript, and we were writing all our new stuff in TypeScript. And this is us a year later. Hey, so the green line is where we were, and we've like long passed that sort of crossover point. You can see that we're still gradually migrating some of those JavaScript files, but again, we're not sort of chasing just migrate for the sake of migration. We're some of that JavaScript code and some of that knockout code is stable. It's not being worked on. It just works. So just leave it. Why are we going to migrate it if we're not actually actively working in that area? So we sort of expect that sort of that conversion rate is going to drop off and sort of plateau a little bit. But all of our new stuff is all in TypeScript, and we're still seeing some migrations. So yeah, I would say that's sort of a pretty successful migration. The React stuff as well, I didn't really talk about this last year because it had started before. And our reason for the migration there, again, is some of those sort of exceptions that I was talking about. So the lack of support around Knockout, the lack of tooling, the lack of availability of libraries, the lack of availability in terms of hiring folks, and some of the features that we were building just required some pretty sort of complex libraries that we wanted to pull in, and they're just more difficult to work with in Knockout, or maybe even sort of untenable to work at in Knockout. And again, our conversion is going pretty well there, so we're over half of our code is React now, when considering the UI elements. And again, some of those Knockout files I'm quite happy to just leave there, but when we're in there and we're maintaining them, we start to find them difficult. That would be a good sort of forcing function to migrate that file. But if it's sitting there and it's stable, just leave it, forget about it. So I would say in general, rewrites, migrations, they're not good unless you have some of these exceptions, but that's different than staying up to date, which is the other thing I sort of want to talk about today. And really, staying up to date is just like good housekeeping, okay? So you want to make sure that you're keeping your libraries up to date, you're keeping your language and your platforms up to date, and you're doing that sort of at a regular cadence. And there's loads of wins for that, right? And most of them are sort of pretty obvious, right? So you're getting all the things that the new versions are saying. So like the new features, the bug fixes, the performance improvements, maybe feature enhancements. Probably you're going to be hoping for some productivity stuff. So when we get to the code, we'll maybe see some of those. You know, you're going to probably have to do it in some cases to get new libraries or to maintain compatibility with old libraries. And just sort of remaining in support. So again, typically, I was actually having a conversation with someone earlier today just about sort of those windows for support and being on versions that have long time support and these sorts of things. And you know, if you don't do this, you can get into sort of a real gnarly state. My wife is currently working on a code base in Java 4. Any Java 4 developers out there? Yeah. So you can sort of, if you leave it too long, you can get into problems. And there's lots of drawbacks, right, to actually staying up to date. So you have to think about it. You do have to think about it. You have to plan it and be careful as you do it. You're going to incur additional testing. So depending on how your testing is set up, that may or may not be that painful. If you've got a really solid test suite, you can do these upgrades and just let the regression suite handle it. But otherwise, you're going to have to sort of do some focused testing in an area that's not necessarily a feature or a bug fix that you were going after. As well as getting all those like new shiny features, you're going to get some new shiny bugs, which is going to be good as well. And again, that's where the testing comes in. Sometimes for some of those productivity gains, there are going to be changes to the language or the APIs or the frameworks, and that could introduce breaking changes, which is going to require you to make actual code changes. So again, that's you having to change your code and make updates rather than just doing it as you develop to new code. So yeah, these are like some of the changes. There's also maybe some undesirable aspects, like for example, I don't know how people feel about it, but sort of React going from classes to hooks was a pretty major design change. And whether or not you sort of thought that change was a good idea, or you now have a code base which is a mix of these, those are some of the impacts from doing this. But you know, there are ways to sort of help you do this and to sort of make that process a bit easier. There's like tooling, so we use Renovate for our main system, and that's, you know, helping us keep our things up to date by basically looking at our dependencies, looking at our libraries, automatically creating PRs for us, highlighting issues with the libraries, and then we can sort of round robin those around the team, and folks can then, you know, like look at those, make sure that they're correct changes, do any additional testing that might be required, and get those in a relatively sort of streamlined way. In our website, we're using Dependabot, and there's like lots of other alternatives. Generally, again, if you've got that popularity thing, if you've got, you know, if you're on a platform or a language that's got that big community, then you'll probably have like decent documentation, migration guides, either written by the maintainers or just like the community, and there may be some tooling as well. So things, you know, like TypeScript migration tools, or we use like Pluto when we're doing Kubernetes upgrades and things like that there. So there's lots of things that can sort of help you do this if you decide to do it. But I'd say like ultimately you're going to have to do it, because if you don't, then your system is going to stagnate, and you're going to get to a point where it's going to be detrimental to your velocity. It's going to be detrimental to getting stuff out the door. It's going to make your engineers unhappy. And the longer you leave it, the bigger that problem becomes, to the point where it's like, okay, now we're in rewrite territory if you let it go on too long. Okay? Now, that's sort of, you know, what I'm saying about bringing your systems up to date, bringing your language and your frameworks up to date. Some of the benefits you get from it, I thought I would talk about some of the code changes. So I've sort of for preparing this, I like looked at some of the features in TypeScript and C# over the last year, and sort of picked out a couple that would be sort of interesting. This is like more than I have time to talk about now, so I'm just going to pick out some of the nicer ones. The first one, and again, I hate Google Slides because you can't like create sections, so I had to have big, massive images to try and like act as like section breaks. So this one is using resources responsibly. So everybody knows the pattern for using resources. So this is obviously TypeScript I'm talking about here. Everybody knows the pattern in most languages where we have this concept of resources, we use them, and we want to clean them up at the end. But an exception might occur, so we want to make sure that the resources are cleaned up in a deterministic way. So One way to do this is to use try finally, which is pretty horrible. So a lot of languages have patterns around this where you can have try with resources, or like here we have some C#, we have using. And again, C# has been pretty nice because even like using, which went in pretty early in the language as this block, and you put the code that you're using the resources with inside the block, the language keeps evolving, and we now have using statements here where you can just have a single line and you don't need to have that level of indentation. And when we leave the block that line occurs in, the resources will be automatically cleaned up. Also, the cleanup and the cleanup operations have evolved. So instead of just having a synchronous cleanup operation, we can have an asynchronous cleanup operation. So we have async usings as well. So these are the kinds of things that we can even see just in this example of C# of how languages have evolved to make your code and your code base easier to work with. So back to JavaScript and TypeScript, it is also now getting this pattern. Okay, so there is a proposal within JavaScript, and TypeScript has this sort of pattern of adopting these things and backporting them into the language, of introducing a using statement. So here we have a using for a resource, and a using will work with anything that has this symbol.dispose method. So if an object has symbol.dispose, you can then put some cleanup operation in there, and then when you're consuming that resource, you can simply do a using. So it looks pretty much identical to C# here. And there's an async variant, which is sort of pretty nice. So you can do some like sort of wacky stuff with this. I'm not saying to do this. I just thought, oh, can I get an example of using this in our code? So here we have a little bit of React. We have a piece of state, which is a flag. We're going to do some operation. We set the flag to true. We do the operation, and at the end, we set it to false. Basically, all I did was search for finally in our code to see was anybody doing this kind of thing. And I found this piece of code. And then we could make this a little bit cleaner by using the using statement by doing something like this. So we could have a custom hook, which basically wraps up this concept of a flag that you set to true, do something and set to false in a finally, and then you can simply consume it as a using. And it's pretty easy to write. It's basically just returning an object that will have a symbol.dispose inside it, which is pretty nice. Other feature, which I thought was pretty interesting, was around super. So this is a little bit of a quiz. It's probably too small. Is it? No, you could probably read this. So can anybody tell me what the code is going to output? So I'm calling a describe function, and I'm calling the onClick method. So the describe method and the onClick. The describe is printing out the name, which is inside this class, and then super.name, which is in the base class. And then the onClick is printing out a statement and then calling the super method. I'll not wait for an answer. You would expect it to print out the name and then the name in the base class, because there's a super keyword and I'm getting no errors. So of course this is going to work. And it doesn't. What you do is you see the name in the derived class, but super.name is coming up as undefined. And this is in TypeScript. So this is in TypeScript. It is not giving me any error. It looks like perfectly reasonable code. There is a thing called name in the base class. Super.name should work, but I'm getting undefined. And the problem is in that the definition of what super does is it basically accesses things on the prototype. And if you know anything about the way JavaScript under the hood works in terms of its prototypical object model, those properties that you assign are not going to appear in the prototype. So in the prototype, name doesn't exist on the base class, or in fact in the derived class. So you've sort of fell for one of the classic JavaScript is not mental blunders. It gets worse if you write your methods as an arrow function. So here we have onClick, and instead of it being a typical class method, we've got an arrow method. And again, before you wouldn't have got any error. Now my onClick is calling super onClick, and it's not actually going to do anything. I'm not getting any errors, but it's not actually going to do what I expect it to do, because onClick is not in the prototype. It only exists in the object. So yeah. JavaScript is a bit mental. This is one of the downsides that I pointed out about TypeScript last year, is that TypeScript adds all the sanity to JavaScript, but it also brings some of the insanity with it. It's an evolution. It's an ongoing process. We're working on it. But in 5.3 with TypeScript, it will look at the structure of your base classes and will give you sensible errors. It's not going to allow this to work because, again, it has to behave like JavaScript, but it will at least tell you, hey, this is going to fail because this is not on the prototype. This is just assigned as a property, which is pretty cool. Another feature that I thought was like really, really cool, and we actually use this quite a lot. This is the movie reference that I stuck in just for Garth to see if he could figure out the movie. So this is Mick Jagger, answers on postcard later, Garth. So one of the things that we use quite a lot in our code base is this concept of const in TypeScript. And const allows us to define an object value and treat it as its most specific form. So here we have some options, and they each have a label and a value, and the label is a string and the value is a string. But because we define this structure, we say as const at the end, it's not that there's a label with some string and a value with some string. It's label with this specific string. It's value with this specific string. So this object only, or this type only represents this one object. And this has some really nice benefits, because you can then take that thing, you can ask what its type, and you can create some definitions that mean that people are forced into using the right values. You're using the type system to force that you're using the right values, and you get some nice tooling around it. So here, for example, I'm creating one of these options. I've started the type label, and when I do my autocomplete, it says, well, the only two possible values are one of these two strings. So I get lovely autocomplete, and if I mistype anything, I'm going to get an error. And if I change it and I do refactoring, it's going to pick it up. And all of this sort of really, really nice stuff. So this is something we use in our code base quite a lot. There's one problem with it, which is that you can still make mistakes. Because as you write out your definition and you say as const, you're telling the compiler, whatever this value is, this is the type. But it means that you can write anything in here. So I have an error here. Anybody spot what the error is? Yeah. So I've misspelled the third label. I've left out the E, which means then when I come to do my autocomplete, I'm only getting two of the options. And if I look at the type, I can sort of see that it's saying that the most specific type to describe this thing is that it's a collection of objects, and those objects have a label and a value, or a label, like that. And this is the thing that as const allows you to do. So in 4.9, they added this satisfies keyword. So this allows us to say, take this type, make it, or take this value, make the most specific type that you can from it, but the values must at least satisfy this shape. So we can define the abstraction of saying, okay, it's a label which can be any string and a value which can be any string, and all of our inputs here have to be of that form, but then give me something more specific, not just value string, value pause, and value continue, and value start, and these kinds of things. And then what you do is you'll get nice errors. So my labl will get me an error. So that's like some of the features, and I have like loads more, so come and talk to me later if you want. But C-sharp's another language that I sort of, again, have a lot of love for. I used to use it in a couple of different jobs ago, and then there was a period of time where I didn't get to use it, and I always said it's great. And now in Gearset I'm getting to use it again. And one of the things I really like about C-sharp is it's quite an old language, but it's managed to stay current, and it's managed to introduce, quite late in the day, some pretty significant changes. And pretty significant evolutions to keep it current and keep it fresh and keep it enjoyable to work with. And when you've got a code base or a user base as large as C# has, it's pretty amazing engineering really to do this. And some of it is from some fundamental design decisions they made early on that allowed them to do some of the stuff. So one of the things they brought in, which was always like a bit of a pain for me in a previous life, because this was some of the code that I was writing, they brought in generic math support. And from like my C++ days, I could always do this kind of stuff, and then in a lot of languages you can't do this. But they've now like added support for this in C#. So what is this? This is where we can basically write algorithms using operators and then make them generic to say, support that for all kinds of numbers. So you can have, ints and doubles and these kinds of things. Support that for all of them. And this is something, like this is a pretty simple thing here. We're basically summing up numbers, right? But I want that to be one method for every type of number. And you couldn't do this before in the language. Some languages let you do this, but a lot of languages won't let you do this. And they've added this into C#11. And the way that they've done it, it required a few features in the language, much like LINQ. If you've ever used C# and have used LINQ, which is sort of equivalent to the Java Stream API, it required several language changes to support it. And in C# with the generic math support, it's the similar sort of job. The main one is static virtual members. So if you sort of try to trace through what's going on here from this code, the key thing is that we're saying, okay, supports summing for any t, but where t is an I number. And if you sort of trace through the interfaces, you'll find this thing called an I number, and inside I number you'll get this number base, and inside there you'll get this I addition operation. And if you look at that, you'll see that it's an interface, it's an abstraction, right? But it has these static members, and it can have static members that are defined, and it can have static members which are virtual. So what we can do, because of the way the operator works and it needs the static signature, we can actually have definitions that work on abstractions that support these sort of static kinds of operations, and then we can override them in our specific implementations, and everything just works. And it's pretty awesome. One of the other little side features that you can do here, or that they had to do, was they had to relax the way the shift operator works. So the shift operators, the 2 arrows to do like arithmetic shifting, that always had a number, and they had to sort of relax that. And now you can do mad stuff, which is what I did for this talk. So again, I come from like historically C++ and using sort of weird syntaxes and using like Boost library and all this sort of stuff. So I sort of went back to that and tried to implement that in C#. So here we have a list, and the way that you can use the list is you can use little arrows to say, send this value into the list. So I'm overriding the shift operator here to basically create a list and then stick stuff in it. Like the hook example in React, I'm not saying do this, it's just a bit of fun for some slides. And I think this is the last one I'm going to chat about, which is good because I'm running out of time, is some of the collection improvements around C#. And this is stuff that you'll see today in C# 11 and some stuff coming in C# 12. So one of the things that's really nice in C# over the last number of versions, and they just keep sort of adding more and more functionality around it, is pattern matching. And again, some functional languages have had this for a long time, but again, adding this into the language in an incremental way with each version, I think is just really cool engineering. So this is the switch expression, which again, they added in a couple of versions ago in C#. So this is doing a switch, and it's deciding what to do with this thing called numbers. And numbers is going to be some sort of sequence, some sort of collection, some sort of list. And we can basically pattern match on it now, so we can do things like say, is it empty? Has it got very specific values in these positions? We can use the underscores there in the third example to say, okay, it's going to be something, something, this value. And we can use those in multiple different positions. We've got this sort of spread operator with the 2 dots. So we can say it's going to be something, 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 or sorry, specific value, and then a load of somethings. I don't care how many. Same at the start. It doesn't let you do something, something on either end, or a range of things on either end with some specific values in the middle. Doesn't do that, but it's, yeah, maybe in the next version. And of course, you can bind into these values other kinds of pattern matching. So you can sort of see in those, the 2 from the bottom there, we can use these OR operators to say, okay, it should be something, and then this value, and then something else. You can do sort of quite sort of complex patterns. You can do relation operators, so it should be something, and then a value that's greater than this value. So here, I'm using the spread to say, okay, it's some collection, and the last element should be positive, should be greater or equal to 0. So some really nice sort of features there that just really simplify, your conditional logic, and then with the switch expression, just folds into your code really, really nicely. And the last thing is just some nicer syntax for writing collections. Again, very similar to Python here. We can basically just do square brackets, and it will infer what kind of collection we need to create. So here I'm creating an array, or creating a list, or I'm just passing it into a function, and it will infer what to create from the signature, which is like super nice. Okay, so wrap up. Keep up to date. Make it part of your process. Utilize the tools if there are some. For big things, plan it and do that consideration, but something you should just do like a regular cadence. And then once you've got those sort of evolutions and you get those sort of benefits and those productivities, encourage your team to use them. So some of those features that I was showing there. And just make sure that you're doing it, because if you don't do it, you're going to get into bother. Don't chase the shiny, but just keep that thing sort of gradually evolving over time. And that's me. Any questions?
Just to echo that round of applause, thank you very much. We do have an opportunity for questions, and Olivia's roving with the mic if there's any questions.
This isn't so much a question as a lengthy comment. No, in seriousness, a lot of talks have mentioned AI, and one of the uses of AI that you see sold online is the ability to help with porting from one language to another or one framework to another. Is this something that you're considering?
Not really. Not really. A lot of that translation is probably pretty deterministic. So deterministic algorithms are probably going to be, as good, if not better, and probably like save the planet by not burning as many CPU cycles and allow me to game a bit more.
There was another question just front row here.
Did you consider JS stock for some of the stuff you aren't going to migrate to TypeScript? Just because TypeScript, I feel like, is a bigger migration, but JS stock's kind of like close enough.
Yeah, not really, because the cost, I know what you're saying, but the cost is quite low. So for some of the migration stuff, we did just do like definition files, but it's fairly lightweight. And again, unless you have like really sprawling files, you can, and because you can do it like on a per file basis, we have just been able to just do it, one file at a time where required. And if it was like a complex thing, maybe it's more complexity than size, then we just stick the definitions right. Some of our migrations did start off as like definition files, and then as people went in to maintain it, then they brought those definitions in and migrated the file. So yeah, it gave us enough of a gradual migration just by going straight to TypeScript.
Hi. So you talked about functional programming a bit, and you sort of said about Haskell at the start. So do you see the value in some of the more stricter paradigms in functional programming, like discriminated unions, monads, and no mutable state? Like, what's your take on that?
Yeah, so probably like the nicest features in C# in recent times, and probably like some of the things that I really like in TypeScript are like some of those functional aspects. So yeah, like discriminated unions and unions of any types and sort of type intersections and things like that. They're great. And like other features that I would miss, like I really wanted a higher kind of type in C# the other day, and I don't have it. And there's some features in TypeScript that I don't have in C#. So yeah, more of that the better. But I still, like there's probably points where you can go like too far. Like say you can too far with the inference. You can probably go too far with trying to make everything one expression. There's probably like still lines. I think I'm in the camp of like the hybrid languages that have all like the best bits of the functional paradigms, but then still allow me to do some imperative bits and maybe even, God forbid, do some OO. Those things sort of work for me. For the modeling stuff, I'd like a few more things from F# brought into C#. I'd like a pipe operator as well. That would be super sweet. There was a proposal in JavaScript for a pipe operator. I'm still fingers crossed for that. So yeah, I do love all of those features, but I still want the community behind it. And that's the thing. Like I will take a less perfect option if I've got like the community and the documentation and good testing capabilities and those sorts of things. It doesn't have to be the purest language. Like TypeScript is not a sound language. It's a pragmatic language. So yeah, it's always still about just getting stuff done at the end of the day.
I have a question here. In .NET, there's like two schools of thought about updating, which is like staying with the LTS versions, like going from sort of 3 to 6 and then to 8, and then obviously some people jump on 5 and then 6 and then 7. What do you, in terms of like since you talked about sort of upgrading is good, but always chasing the new thing, I guess what are you doing at Gearset, and what would you recommend there?
Yeah, so we generally do those major version updates. So we're on 7 at the moment. And this is where I tell you that we encountered a garbage collector bug that caused us all sorts of pain, and then we had to get an option to basically use version 7 with the version 6 garbage collector. But still, it's still a good process, because otherwise you're just giving yourself like bigger jobs. But I would say you need to have that testing, you need to have that planning around it. So you may encounter issues. You still may encounter issues with the long-term support versions as well. But I just have a school of thought of just make it a regular small task than a big task.
And Olivia, there was a question at the back of the room over there. If you just raise your hand again, thanks.
Hello. I wanted to ask, what are your thoughts on the recent major frameworks that have dropped TypeScript and the very sort of like blogs that have been coming out in the last sort of week or so that have been very anti-TypeScript? And also, you were showing some really cool stuff doing in C#. How do you know to sort of go out of your way to use those cool little shortcuts and stuff instead of writing the more complicated logic?
So, sorry, I couldn't quite hear. What was the last bit there? Sorry, using shortcuts. What was it?
So, like the pattern matching and stuff. How do you sometimes get your team or yourself to go out and find those shortcuts?
Yeah, there's a piece around sort of like knowledge sharing. So like we'll have like Slack channels and things like that where people can share stuff. Pairing, code review, those are generally how you pick them up. The IDs are generally pretty good as well. So the IDs will say, hey, you're doing this, maybe you want to convert this. Again, I'm sort of thinking of like say JetBrains tools and using like Rider and WebStorm and these sorts of things. So the IDs are a good way to do it. Obviously just people are generally learning anyway from reading various different feeds and stuff like that there. So it's just through that sort of, in our industry you can't like not learn the new stuff. And then you may not find everything, but another thing with the language stuff is that with the cadence that these come out at, they're, at least with TypeScript and C#, they do these like what new docs. So I have like, so the reference here, and these are just awesome summaries. So like, you know, in a couple of hours you can like get up to date with everything that they've been working on in the last 6 months or a year. So yeah, and then what was the previous question, sorry?
A bunch of major frameworks have recently dropped TypeScript, and there's been a bunch of sort of blogs by people in the programming community saying that TypeScript is dead and it's really bad, and JavaScript has a lot of the functionality that TypeScript kind of came out to fix. Kind of like how Yarn came out to fix NPM, and then NPM added the Yarn features. So what do you see happening now with TypeScript?
I don't know, I guess I can't tell the future. I'm not too worried because yeah, programmers and engineers are good at saying this thing is dead, and it's not really. Again, we're just seeing it sort of the value that we're getting from it now, and yeah, can't see it going away anytime soon.
Thank you. I don't know if there's time for just one more question.
Hi. Question about vulnerabilities in your knockout code. How do you deal with those at the minute?
Sorry, I'm having great difficulty hearing.
Yeah, so question about vulnerabilities. You still have some knockout code in your code base. How do you deal with those? What's your policy?
What's our policy?
Yeah, to fix those vulnerabilities.
On vulnerabilities?
Yeah.
Yeah, sorry, on vulnerabilities. Yeah, so again, we use some other tools like Sneak to try and identify those. In our front end code, there's not too many there. Yeah, so we have sort of monitoring systems to track those. At the moment, it's a fairly sort of stable, static thing. And a lot of the libraries around it can update. So again, like Knockout is using all of these other dependencies that will stay up to date. You know, so we're not seeing anything with that at the moment.
Okay, well, thank you very much.
Cool, thank you. Come and see us at the stand.